Hello judges, we are the Quantum Recreators, a group of 8th graders from Johnson. Today we will be talking about our robot design presentation. First, let's begin with the name. Our robot's name is Advanced Driving Based Assembly, but the robot's nickname is Scorpion. Here I will be telling you why are we using Advanced Driving Based Assembly. Well, I'm going to give you 3 reasons why. First reason is there has a modular design and easy customization, allowing you to put on attachments. The second reason is the robust construction for durability and its powerful motors that are connected with attachments to do certain missions and tasks. And the third reason is the expandability for additional features, which allows you to freely attach or freely move the attachments anywhere you go.
Now, I'll be talking about the innovative features of a robot. So, one of the innovative features of a robot is that it's symmetrical, and this helps distribute weight evenly. And since it distributes weight evenly, it can help our robot navigate on board easily. Secondly, our center of mass is in the center, and this ensures that the robot is stable. And this can help keep our robot stable, and it can help us put attachments on it easily and take it off. And lastly, our robot has organized cable management, and this prevents the cables from interfering with the motors, which can help us successfully do our missions.
So some additional features to our robot would be the attachments. So for qualifiers, our attachments used to be axle-based, but we realized that was a bit of a problem for time. So we've tried to use locking pins to make sure that the attachments were more securely locked on. But we also found that was a bit more time consuming. So we decided to use attachments that were easy to put on and easy to take off. Like for example, this attachment, where it's easy to put on and take off, making it so there's not too much time waste when doing our missions. Another feature is that the back end of the robot has a red marker on it to make sure that, say for example, we're aligning a mission in a diagonal way. We can make it so that this is used for alignment to make sure that our mission is completed properly.
Now I'll be talking about our attachments. Today we have 2 types of attachments. First, we have our arms attachments, and then we have our passive attachments. So first, our arms attachments are basically regular attachments, the ones that are powered by the robot's motors. These attachments are very efficient, and they can be used to complete tasks with strong capabilities, such as the submersible. The second one we have is passive attachments. Unlike regular attachments like our arms attachments, these don't rely on the robot's motors. Instead, they rely on their environmental factors. This is an example of Feed the Whale, where as it approaches the whale, it eventually touches the yellow bar, which raises the compartment during the throw. And lastly, we have our retention attachments. Our retention attachments are used to complete collecting missions, such as collecting krill or coral, without them spilling out. As you see here, there is retention attachments used with rubber bands that prevent the krill and coral from exiting out, and this can be used to complete another mission, as we're using it to complete the anglerfish mission.
So now I'll be explaining how we changed our attachments from qualifiers to safe. One of our attachments is for the raise the match mission. First it was just this attachment, but without this yellow. But we found out that if the robot went way too forward, the raise the match would drop down and trap the robot. And also, if we went way too fast, it would push the mast up like this, and we wouldn't score any points. But what we figured out, if we put a limiter, it would make sure the axle of the raise the mast would just stop right here, and the robot not make it go too forward. Another one is for our moving the submersible over. We first used an arm attachment to raise the thing, but we figured out that was taking way too much time and it may not have enough power. Then we resorted to a passive attachment that would push down the lever and then retrieve back home.
Now, let's talk about strategy. You see, not only do we strategize the board, but we also strategize our team's productivity. You see, we have a large team, 8 people, and since on the robot game board, you have 2 sides. So we decided we could just split into two teams of 4. And in these 4 people, you have coders, positioneers, and people who make attachments. This made our productivity go up a lot. And now about our strategy. You see, we decided to start on the blue side because on the blue side, it scores a majority of the points with the majority of the missions.
Right. Thank you. We have to stop you because we're over time on the presentation. But we're going to go ahead and ask a few questions, and then we'll get you on your way. All right?
Go ahead, Josh.
Well, I know you were just getting your strategy, so I guess I'll ask that. How did you plan on which missions to do and what order to do them in?
So we first prioritized each mission using how easy it was to complete and its complexity. So we put them, shown in this, we put them in the easiness of each mission and how many points it scored. Then we put the complexity of each mission. We ordered them so as an easy mission was able to give a more amount of points in a less complex way than a complex mission giving less points. We would do that. We would prioritize that one as it would give us more points.
Another form of making our strategy was based on simple stuff. Like in our regionals with Plan A, it was based on getting as many points as possible, right? Just doing the missions straight. But with Plan B, it was trying to get a majority of the missions with less time. But now you see, with our new strategy, Plan C, we both get a majority of the points in less time. Meaning we can get a lot of points and save time.
Excellent. Okay. I'll let you go ahead.
So, for the design, you guys talked about splitting it into 2 different groups. Did you ever have cross collaboration between the 2 groups, or did you mostly stay in your own areas?
Yes, we actually did. So as we split it into 2 halves, there were some missions that collided right in the middle.
Right.
That's where we, a few people from each side of the board came together and collaborated the best way to do that, because we could start from the blue side or the red side. We would put the cons and the pros, and then after that, we would all agree on one side to start from and our attachment.
Excellent.
Go ahead, Josh.
All right. So as far as say your attachments, building and stuff, how did you test and iterate on which attachments to use?
So basically, as we started throughout the season, we decided to develop attachments just using from like the handy book and stuff. And as we looked at these attachments and tested them out on our board, we modified them and adjusted them into helping gain more points. And later on, we discovered passive attachments, which became a really crucial part into our robot game, as they helped us score more without utilizing the robot's motors, which was found innovative and creative. And as we went through on the season, we developed and kind of adjusted our attachments more depending on those.
So one of these is, for this one, we use this for qualifiers, but we found out that it was inaccurate as it had a lot of movements. Like first, when we were aligning it, this would have to stay up, and then this would be locked in, so the pill would stay backwards. And then when the door opens, the door would have to push into the yellow to release this. We found out that it was way too complex and was taking up a majority of our pieces. That's where we found this one. It uses a less complex mechanism, and it only uses gravity. As the robot pushes in, the base hits this, which as it starts dumping, it would hit the yellow lever and push the mouth open, and then the grill would get dumped. This uses the same amount of pieces as this, but this is only half of the attachment because we had to break it to make this as we were running out of pieces.
So, for this project, for the development of everything, what was the toughest challenge that you guys faced?
So the toughest challenge we faced was probably collaborating with each other. So we were like working pretty well with the groups, and we also had an innovation project. But then so as we were switching roles, we switched roles together so everyone would get a chance and stuff. It was a little hard to adjust to these new roles, but as everyone taught each other with teamwork and responsibility, we managed to get through the season, and the same method was also applied to our innovation.
Another challenge we found was getting the right robot on. You see, this year's season has a variety of robots you can use, because there's a lot of space, right? But if we made a robot too big, it would affect the navigation process. So that's why we had to incorporate it being both small and still That's why we made our robot compact, so it can navigate easily using the space provided.
Okay, and then one last question for you guys, unless Josh has another one. For the whole development process, was there one item, one challenge that you're most proud of?
So one of the major challenges that we are actually proud of is how we grouped our missions together. Because if you group it in a not effective way, you could lose time, or you could also lose the positioning. That's why we grouped missions that use the same attachment, same attachment, and could start from the same positioning and was near each other. Like for example, we grouped the raise the mast and the coral buds and the scuba diver. Our robot would first raise the mast, and as it backs up, it would hit the coral buds, and then attachment would get the scuba diver. That way, we were able to save around 10 seconds of time. Then splitting the mission into combining one. And another one is we have two motors on the back of each one.
Okay. We are done, out of time, but that was an excellent presentation. Thank you very much, guys.
Thank you for spending your time with us. Listening
Thank
to
you,
our
judges.
project.
So we'll let you guys get on to your next event and have fun out there.
Thank you.